There are natural pre- and probiotics. Humans and our humanoid ancestors have been eating them for some 200,000 years. They feed our guts, which controls our appetite, so we don't get fat and sick. They enhance our immune system, which protects us from infection. And they make many of the complex chemicals we need to rebuild our body parts as they wear. They are called plants, and they grow naturally in living soil full of nutrients and biology. Some biology breeds in the soil, while other species breed in the guts of the larger animals, like worms, when they pass into the plants themselves, and then onto feeding our guts. It is a great package of a broad spectrum of beneficial biology, all wrapped up in a protective shell which can pass through the acid in our stomachs to feed our guts. You've got to admit it, nature sometimes does some pretty smart things. All was fine until about 50 years ago, when it was decided that it would be more economic to manufacture our food in factories or factory farms and wrap them in plastics just like any other industrial product. And it was incredibly successful. Food was cheap, tasted good, and was very convenient, apart from much of the population getting fat and suffering from chronic diseases. I'm an engineer and innovator. I was selected by the Institute of Engineers as one of the top 100 innovators for my work on computational fluid flow. But my interest of late has been in how water and nutrients move through the soil and into plants. I was a pioneer of wicking beds, and I decided I should develop them into a system for growing gut food. I call them Gbiota beds, and they work great and use pumps and timers and a neat system called a leaky dam, so the soil is at the Goldilocks moisture level, not too wet, not too dry. They were developed for commercial production to compete against industrial chemical agriculture. But I thought we really needed to educate our kids so they really understood about the need to feed our gut. Not just textbook learning, but actually experiencing growing and eating real gut food. Gut food is an acquired taste. I needed to get Gbiota beds into schools. So I developed a dead simple system so that any school can set up their own Gbiota bed using waste food and other green waste as the primary input, so the next generation can make the switch to a circular society based on recycling rather than exploitation of our planet. This video shows how to build these dead simple Gbiota beds. This information is shared with schools under the Creative Commons systems, which means the information can be used free of charge for non-commercial use and shared freely with others, but the source of the information must be recognised. I can also provide technical support via email. To see all my videos and articles on how to build and operate Gbiota beds, go to www.gbiota.com. While Gbiota beds can be grown in boxes, essentially modified wicking beds, it is easiest to make them directly into the soil. This way they benefit directly from the natural soil biology. It just takes a strip of land about 2 meters wide and between a couple and 10 meters long. The bed has 3 layers. The bottom layer is very rich in nutrients and is where the beneficial biology grows, and also acts as a food and water reservoir. This is the breeding layer for the beneficial biology. The next layer up is where the bulk of the roots grow, the rhizosphere. Again, this is rich in nutrients and biology, but not too concentrated, as this makes it difficult to absorb the water and nutrients. Plants absorb water by osmosis, where the weaker solution moves into the stronger solution in the plants. If the concentration in the soil is higher than in the plants, it literally sucks the water out of the plants and they die. The top layer is where the seeds germinate. Seeds have all the nutrients they need built in, so this layer need not be nutrient rich, but must have a good fine texture for close contact with the seeds, and be moist without being wet so that the seeds will germinate properly. Normally beds are rectangular, but this need not be. In this video I've had to fit the bed around my mango and other trees. The base of the bed needs to be flat. Commercially, this may be done with laser levelling equipment, but here, for the benefit of schools, is the old-fashioned way. I mark out what I call the lead corner and edge, which I use as a reference, then estimate where the other sides will be. I make a good job of this lead edge, cutting it nice and square to the right depth of 150 millimeters. I measure out approximately where the other edge will be, which, using 2 meter wide sheet, should be about 170 millimeters wide. But I make sure that it is wide enough, but I don't bother about getting the edge exact. I will do that later. I'm using 2 meter builder's film. I want the base layer to be 150 millimeters deep, so I dig out the soil, making it as flat as I can by eye. Now let me be honest, I've made lots of bed and I never get them properly flat by eye. My soil is a silty clay, so I can just partially fill it with water to see if it is level. On sandy soils I would have to use the builder's film for testing. As you can see, I've not got it right as the top end is too low, so I just rake the soil around until it is more level. There's a trap here, as the lower level I have filled will have very wet soil and will contract as it dries. So I let it drain and come back in a few hours. Level with a rake so it is smooth, then partially fill. This time I can see while it is a lot better, I've overfilled the previous low area, but it is close as the whole base of the bed is covered with just a little water. I can now make a correction to this area I've overfilled and just let the water drain away and rake the soil with the back of the rake. I use the prongs on the rake to measure the depth of the water, and with raking as the water drains I can now get the base level. I rarely get it right first time and need a second go, but if I need 3 goes I've made a serious error on my first attempt. But no problems, just a bit of extra work. To see all my videos and articles on how to build and operate Gbiota beds, go to www.gbiota.com. Now, the soil is pretty wet and squashy, so I make sure that I don't stand in the bed, so I need help in stretching the builder's film over the bed. We drag it right up to the reference corner. I then fill in the lead edge with soil to hold the plastic in place. I then go to the opposite edge and simply dig out or fill in this edge so the depth is correct. Again, this could be done with accurate measurement, but I want a way that kids can make the beds themselves. I then work on the top and bottom ends. Because I'm having to work my bed around the trees, the plastic is too long, so I just fold the end over and fill in with the soil. Folding the edges works perfectly fine. I could try and cut the plastic to size, but if I goof up, as everyone can, and overcut the edges, I may have to scrap the plastic and start again, so folding is much more practical. I now lay a length of regular ag drainage pipe down the centre of the bed, so there's an overhang so I can flush the pipe out. I don't want this underground pond to flood over the edge, so I just scoop out a bit of soil so the water will overflow. If I want to make this an automatic bed, I will install a sump with float valve and pump. This would be set below the level of the bed, allowing the bed to drain completely. But I would build a leaky dam to hold the water back to give me the flood and drain system, which distributes the water without leaving the soil saturated. Now I fill the base of the bed with any old green waste I can find. This could be food waste, garden prunings, lawn cuttings, or whatever, as long as they are clean and not contaminated with toxic chemicals. I want this to compost, so I need to add some nitrogen. My preference is for chicken manure. I can simply buy a 20 kilogram bag, but for this bed I bought a truckload of a mix of dried chicken manure and mill mud. That's waste from the local sugar mills. This is really quite acidic, so I add a bag of dolomite. Compost enthusiasts go to great length to get the carbon-nitrogen ratio right, but honestly, I find if you have plenty of chicken manure, it will decompose quite happily, taking everything else with it. The only issue is to ensure there is plenty of air. Again, compost enthusiasts expend a great deal of energy turning and aerating. I just flood, which expels all the excess air, then allows it to drain back so it sucks in fresh air. Anyway, I'm old, and that is my excuse for being lazy, but it just happens to be true. I spread the chicken manure and mill mud mix to form a flat plateau. It will drop down with time as the green waste decomposes. I place my compost bin where I can easily reach it without walking on the bed, then spread the soil layer on top to form the rhizosphere layer. I need to add minerals, which I could mix in with the soil, but this time I'm going to save this for the top seed growing layer. To see all my videos and articles on how to build and operate Gbiota beds, go to www.gbiota.com. No one can argue with anything I have said till now. It is obvious that we should be recycling all our waste food and manure, rather than let it make methane in landfill. But some people may not agree with what I do next. I look at my friends' gardens, and they are so neat and tidy, with plants laid out in a nice grid, with rows 143.2 millimeters wide and plant spacing of 98.6 millimeters, just like an army parade ground. But I'm interested in how other cultures grow their food, and have been to many traditional societies in Africa, the Americas and Asia. They have a totally different philosophy, and will pull up a plant and replant it with another plant, maybe a different species, so it is all iggly-piggly. But some of these societies have been growing food sustainably for thousands of years, as was documented in farmers of 40 centuries. This is really a question of personal choice, but I rather like the random approach, planting multiple species of plant at the same time, knowing full well that some will grow and others will fail. I call it Darwinian gardening. But I do suggest this for schools. There will always be some plants which will grow, and a bit of success is important for the kids to remain interested. It is also quite fun seeing which species grow or fail. I typically leave some plants to reseed for the next generation. Very satisfying to grow your own seed, but no real point as I can buy seeds either from a seed shop, but to actually go to the health shop where they have a wide variety of weird seeds to eat, but typically they will grow quite happily, and they're cheap. The aim is to grow natural pre- and probiotics, which mean that we cannot use any toxic chemicals. They may or not hurt us, but they do hurt the biology we are trying to grow. These chemicals do work, no doubt about it. They may or may not cause us harm, but they certainly damage the biology. That is what they were developed to do. To try and grow plants without toxic chemicals creates the two major problems of weeds and pest. While I have no complete solution, this is the method I use, which enables me to cope. I simply add a mix of soil, compost, minerals and a mix of seeds to add to the top layer of the beds. This compensates for the level of my beds dropping as the organic matter in the layers break down below.
This is radish.
I make my mix with 3 buckets of soil, another bucket of compost. I'll take out all the large creatures like worms and the soldier fly larvae, which, at least in Queensland, always find any compost, plus a whole mix of various seeds, plus some biomin, which is a mix of rock dust minerals inoculated with biology. I just mix this all together with water to make a nice messy slurry, typically by hand, as I find this works best and avoids damaging any creatures which I missed and would be killed by hard tools. I let this stand overnight so the water soaks into the seeds, and the next day I spread the sludge on the surface. For the big bed I may use the back of a rake, but on small areas I just spread by hand. In summer, in my hot, dry, windy climate, I find I need to sprinkle the beds until the seeds have germinated. In cooler times, there may be just enough water in the slurry for germination. With a Gbiota or wicking bed, we water from underneath, so the surface should be dry. This is very useful as weed seeds are less likely to germinate. But when we are seeding, we need to check the surface moisture to make sure our seeds germinate. Once they have put down roots, they will grow, even when the surface is dry. It is best to avoid wetting the surface, as this helps to control weeds. To see all my videos and articles on how to build and operate Gbiota beds, go to www.gbiota.com. As I have said, the whole point of Gbiota beds is to grow food to feed our guts, and that means not using any toxic chemicals. In this video, I want to look at the techniques we can use to get by without toxic chemicals and grow gut food. The two big problems we face are weeds and pests. So, although there are plenty of weed seeds flying around in the wind, they do not actually germinate on the dry surface of a Gbiota bed. It is very difficult to kill seeds. So if we want to reseed an area, I will sprinkle the area for a couple of weeks before I seed to get the weed seeds to germinate, which I can easily work the surface to kill the fresh seedlings, and then apply my seed sludge. Putting a piece of old carpet on the area to be seeded can be beneficial. The soil can be kept moist so the weed seeds germinate, but the lack of light will kill off most of the weeds. It is far from perfect, and I still have to hand weed, which I often do with a process I call water weeding. Basically going out with a high pressure hose and blasting the weeds, which enables me to pull the entire weed and root system out of the soil. Some seeds, like nutgrass and onionweed, are very persistent and difficult to kill. If you leave just a bit of root, it will regrow. Water weeding helps to remove the entire plant and is not too bad a chore on a hot summer's day. Much better than digging. We may not like weeds, but they are highly effective plants which are very good at pulling nutrients out of the soil, so they are actually an asset. I often have compost bins spread around the bed so I can recycle them. I'm a bit of a recycle nutter, and I'm always looking for converts. This does not solve the weed problem, but at least it makes it manageable. Insects are a bigger problem. Keeping the surface dry certainly helps keep away the slugs and snails, which just invade if the surface is wet. But cabbage moths are on a different scale and will decimate any pure brassica crop. However, by having a mixture of plants, particularly if it includes plants like buckwheat or marigold, which are just decoy plants, or resistant plants such as spinach, would allow the susceptible plants to gain some level of maturity. Plants have evolved a system of communicating with each other by an underground system like the internet, but actually mycorrhizal fungi. If one plant is attacked, it will send out signals through the underground internet, so they will generate the chemicals they use for defense. This is how plants with no natural defense systems have survived and flourished over the ages in the wild, and is one reason why I like having multiple varieties. Some plants, like buckwheat, are natural homes for predatory insects, which will prey on the pest insects. I once planted buckwheat as a food crop, but it did not suit me. I just left them there, and they grow and reseed quite happily with no work on my part. I'm not sure how effective they are, and they certainly haven't halted the swarms of grasshoppers we get, so need a more effective strategy. The real trick is to grow baby greens, the step just beyond microgreens. They are full of flavour and nutrients and make excellent smoothies, wraps, or just a good old veggie and peanut butter sandwich. They may be the most nutritious and tasty phase of plant growth, but they also pretty much solve the insect problem. I just let the plants grow and eat the fresh young tips as they emerge, a sort of beaten to it approach. I leave the older leaves in place, and the insects may feast on these, but the plants will typically keep on growing and will eventually seed for my next generation of plants. With an automatic system, we set the timer, or sunshades if using a solar system, to give a pulse of water for a few minutes several times a day. The excess water drains back through the leaky dam, so the bed is always moist, but never really saturated. What I call the Goldilocks moisture, not too wet and not too dry. This works really well, but I want a simple system that kids can manage themselves, which is why I developed the manual system for schools. With this manual system I'm suggesting for schools, we just make a small observation hole by hand so we don't damage the plastic, and we can see the water level right down to the base of the bed. We put a hose into the compost bin so the water goes through the compost bin and into the bed, and as soon as we see the water we just turn off the hose. We just wait until the base is dry and repeat small top up. How long depends very much on the climate and what plants are growing, but this watering may be needed several times a week. This is different to a wicking bed where we may fill the entire base with water, which may be enough for a week or more. Having the soil saturated for a long period of time is not good for the biology we are trying to grow. But in a school environment we face the problem that the beds may be left unattended over the weekends and a short holiday. We can solve this problem by giving a much bigger watering so the lower reservoir has much more water. In essence, we are converting our Gbiota bed into a short-term wicking bed. This obviously depends on where you are situated, so a little experiment is needed to see how long the water reservoir actually lasts. I can tell you that as a fact, in the dry tropics where I lived, the bed would dry out over the long summer holiday. Fortunately, baby greens grow within a few weeks, so that may be acceptable. Or alternatively, it is not too big a problem to fit an external reservoir with a float valve to make an automated system. The picture shows a typical reservoir and solar powered pump. To see all my videos and articles on how to build and operate Gbiota beds, go to www.gbiota.com. I have a message for the next generation, the kids of today. Humans have become the dominant creatures on Earth as a result of two great skills. We are cooperative and we are innovative. Life for most people has simply been getting steadily better and better. But this will not continue unless we learn to change. We are destroying the systems on which life depends, our Earth and its soil. We need to learn to change to a system where innovation benefits all of humanity by developing technologies where we recycle rather than exploit the Earth. Gbiota beds are such a technology. The raw materials are food and green waste, which would otherwise pollute the atmosphere. Manure, which is a valuable resource, and volcanic rock dust and water, which we must learn to manage better. We can send rockets to Mars, but we cannot live without the humble earthworm, which forms part of the great soil web of microbiology on which our lives totally depend. It is just a fact of life that there are some nasty bugs around that make us sick or kill us. They don't actually mean to kill us. All they really want to do is eat and breed inside us. But they sometimes get it wrong and kill us, which is no good for them or us. Us humans are really very good at some things. We are really very good at making toxic chemicals which kill living things, often all living things. But we can be more selective and have antibiotics which are often broad spectrum that can be quite targeted to specific bugs. We even have vaccines which don't actually kill anything but train our immune system to kill specific bugs. But what we tend to forget is that of the trillions of bugs on Earth, only a few are really bad. Many are pretty apathetic and are the bug equivalent of the couch potato. You just want to sit on the couch and watch TV. But what we really fail to appreciate is that bugs were on this Earth first. They helped to convert inert rocks into soil, and there would be no life on Earth as we know it if it were not for these good bugs. These good bugs are everywhere, in the soil, in our guts, and in fact all over our bodies, and they are protecting us and controlling the bad bugs. If you have a good selection of good bugs acting as your personal defence force, you are much less likely to die from the bad bugs. Every year we hear some outbreak of E. coli with people dying, but right now I and probably you have E. coli swimming around inside us and causing no harm whatever. That is because the good bugs are controlling the number of E. coli. They don't kill them, but they can outcompete them, so they don't have adequate food and can't breed effectively. And this system works. has worked for hundreds of thousands of years because the conditions favour the good bugs at the expense of the bad bugs. It is just a question of managing the conditions. It is the same with Gbiota beds. The basic inputs, food and green waste, manures, rock dust, worms, inoculants, could end up, if the conditions were bad, as a really toxic brew, bringing out some really nasty bad bugs. And if the conditions are right, we will breed up the really beneficial biology, which is essential for a healthy human life. The key is in the moisture level. If it is too wet, we will breed up the bad bugs. If it is too dry, the good bugs won't breed, so we need the Goldilocks moisture level. Not too wet and not too dry, just right. We do that by the partial flood and drain system, where we wet the soil, then let the water drain away. And we don't have to have a PhD in microbiology to tell us if the moisture level is right. Worms are like the canary in a gold mine. If we have a good density of worms, we can be pretty sure that the moisture level and hence the microbiology is good.